Hey friends, now let's get into another example. So we solve another example for banker's algorithm to check whether the deadlock condition is possible for the given situation, or whether the situation is safe or unsafe. So that's a given problem. So only the allocation has little modified compared to the previous example. So the A, B and C, we had 10, 5 and 7 instances of the resources, and out of which these are the allocated one, and these are the maximum required. So these are already allocated, so this is what is currently available. Let us see, can we allocate to the processes these available resources or not. So start with 230 is what available. 230, the requirement for P0 is 743 and we have only 230, therefore P0 can be taken up. Therefore let us check for P1. P1 requires 020. Yes, 2 units of B is required and we have 3 instances and hence it is possible. So let's continue with P1. So P1 gets 020 and then it continues its execution, and once it is completed, then the allocated 1302 which were already allocated will be released along with these 2 units of B. So that makes totally 5. So 3 instances of A are released. So 2 were available earlier, now it becomes 5. 0, nothing changed for B, and 2 increased for C. So now we have 532. So after that, if we look for P2, then we require 6 instances of A, whereas we have only 5 instances of A. Therefore we cannot take up P2. So let's check for P3. P3 requires 011, so 011. So yes, we have 32 of B and C respectively, therefore we can take up P3. So once P3 is taken up and it is completing its job, then this earlier allocated 211 gets released. So A gets added with 2 more, so that A becomes 7, B added with 1, so B will become 4, and C gets added with 1, so C becomes 3. So 7, 4, 3, that's what we have now available for next allocation. So if I look for P4, then 2 instances of C are required, so we have 3 already available, so we can continue with P4. So P1, P3, P4 are done. Next let me try back with P0. 743 are so once P4 is done, so these 2 units are released, therefore now it becomes 5. So 745 is what available, and 743 is what required, therefore we can take up with P0 and P1. P0 completes its job, then 1 instance of B gets released, therefore it now becomes 755, and then check it with P2 which is not yet executed. So P2 wanted 6 instance of A, now we have 7 instance of A, so we can take up with P2 also. So P0 is done, P1 is done, P2 is done, P3 is done, P4 is done. So that's what all 5 processes are given a chance, but in this order: P1, then P3, then P4, then P0, then P2. So in this order if we allocate, then all the processes will complete, and therefore we can say that the situation is safe. So if we look at this, then the situation is safe, then whatever were requested by the processes can be allocated, and there is no chance of getting into deadlock. And therefore with this example we can see that the banker's algorithm will at the end tell that the situation is safe, and hence all these resources can be allocated in this order of execution. So that is what we have for a second example. We have many more examples to understand, so let's look them in the next session. Thank you.